Welcome to the Postgraduate Showcase for the MSc Data Science and AI for Creative Industries at the Creative Computing Institute at University Arts London. My name is Terence Broad and I'm a Senior Lecturer on the programme. Our programme offers a unique opportunity for students from a wide range of academic backgrounds to reorient their studies and learn applied STEM skills to a creative industries context. We teach state-of-the-art data science and AI techniques and technologies to give our students industry-relevant skills so that they can go on to pursue a career in this rapidly growing field. Data and artificial intelligence are becoming increasingly ubiquitous in our daily lives and in the creative industries themselves. We believe strongly that the diversity of backgrounds and experience of the people developing and working on these technologies are crucial for these technologies to be used in ways that benefit wider society and the industries that they're being applied to. Using these technologies in ethical ways and ways that promote social justice is a main focus of our programme and one of the things that uniquely defines it. Our programme offers a foundation for complete beginners in computer programming and mathematics that underlie these technologies, as well as a large array of practical skills for how they are then applied in creative industries contexts. We teach natural language processing, recommendation systems, and AI techniques for analysing and generating different forms of media, such as images, audio, and text. This showcase will show you a selection of student projects from the 2021-22 cohort of the programme. I hope you enjoy it. Our next video is going to be by the student Apurva Kapoor, who's been using machine learning for fashion trend analysis.
Hi, I'm Apurva and I did my final thesis project on analyzing fashion trends using machine learning. So, as we all know, fashion is an indicator of telling us how the society's ever changing moods are and what's going on. And I think we can use machine learning to be up to date with the current fashion trends that are going on in the market. And it could be of use to a lot of people, like the designers, the e-commerce, the fashion houses, the researchers. And for this model, I used the data set called Clothing Co-Passing. It is an intricately annotated data set with various images of clothing articles. And then I went on to use a data set called Fashion MNIST, which contains a lot of examples of training and testing data set with clothing image articles again. So the model is as follows, as you can see. So the first step was removing the background of the images as per the given mask in the clothing co-passing dataset. So I removed the background of the images and then I went on to manually crop these each individual piece of clothing article and create a new data set of it, like skirts, blazers, trousers. A new data set was created with each individual piece of clothing article. Then I went on to run a component matrix analysis to see in this new data set what could be the most number of occurring piece of clothing article. Like, as you can see, pants were the most prevalent piece of clothing article in this new data set. Following that, I ran cluster analysis to see how the clusters might be performing and what piece of clothing article goes well with which other piece. And after that, I attempted to run a color wheel analysis. As you can see, the range of the color wheel starts from 0 to and ends at 11, 0 being red and 11 being red to violet. So this can give us an understanding of how the color scheme is throughout the data set and like what sort of color would be most frequently occurring throughout the data set for us to know what color might be trending at the time when the data set was created. And lastly, I went on to use transfer learning and the Fashion MNIST dataset to create a label and classify these images into different clothing articles. And in the end, the limitation of the model was that the number of images were a bit limited. So this could overall impact the performance of the model. And this was only built with my knowledge and understanding. But the project can be taken further on and can be fully developed into a virtual stylist of sorts. as you can add a recommendation model to it, and also it can predict new outfits based on the cluster and color wheel analysis that we did. And that was it. Thank you so much.
Our next project is going to be by the student Ashwati Pillai, who's used AI models for timbre transfer and audio as tools for autistic stimming.
Hi everyone. Today I'd like to talk to you guys about my thesis project that I worked during the summer. My main motivation to apply to this MSc program was to kind of learn relevant technical skills that I could use to create more accessible creative tools. And while on this course, I really enjoyed learning about AI and its applications in music. And it got me thinking whether timbre transfer, which is a deep learning technique that essentially allows you to change the timbre of one instrument to like another, whether it could be used as a tool by autistic people to self-stimulate or stim in particular. So my focus was on auditory stim, such as repetition of speech or sound, and whether such a tool such as timbre transfer could help encourage that process. So traditionally, autism research has heavily been focused on kind of curbing autistic stims. Hence, my sort of focus was to kind of redirect that sort of line of thinking, given that recent research and also accounts from autistic people seems to suggest that stimming might actually be quite beneficial for self-soothing and to communicate intense emotions. And the reason why I chose music production as like a tool is because autistic people do perceive music significantly differently. And there have been a lot of studies on how music creation enhances executive function, which is something autistic people might typically struggle with. And technology can help in this regard, given that so sometimes acoustic instruments like playing a guitar or piano might be hard for some autistic people. And yeah, again, the focus of this entire project was to kind of encourage stimming and to help like autistic well-being, which is sadly not like the usual like focus on autism research. So when it comes to timbre transfer, there's lots of different approaches. I decided to go with the TDSP one and the Fourier-based one for this project and try to compare both of those. So there were two research questions that I had. One was, can timbre transfer models be used as a tool to kind of aid sensory dysregulation? And second was, between the TDSP and Fourier-based approach, which one would be more effective when it comes to autistic stimming? And then, yeah, for the first part of the research question, I decided to like recruit autistic participants via autism advocacy groups and my personal networks. A lot of people showed interest, but I decided to go with 6 and made sure they were all very diverse when it comes to cultural and musical backgrounds. So that's the data that was collected prior to the interviews. They were all musicians, apart from one who wasn't a musician. Yeah, when it comes to the interviews, they were all hosted on MS Teams, and an option for video, audio, or text chat was given to account for varying communication needs. And a distress protocol was also included in case speaking about stimming or curbing stims, particularly, brought up any traumatic memories. And then after the interviews, which was heavily focused on just trying to understand the participants' relationship with stimming and music and technology, I did like a quick sort of user test on an existing timbre transfer solution, just to kind of get their views on, if this is something that could work. And then I analyzed all of that data. I did a thematic analysis and also did a bit of affinity mapping to kind of see if there were any common pain points. And these were the themes that were identified from all of that. With stimming, I think this one will be more easier to kind of digest. So when it comes to stimming, participants mentioned that they stim to kind of, manage intense emotions and stuff, and kind of suppressing stims would be sometimes very painful. And they did suppress stims because of social stigma. When it comes to music, again, given that like most of them are musicians, they had a very close sort of relationship with music and listened to music quite regularly. And with technology as well, all participants were aware of emerging technologies and were quite excited about it, but there were certain concerns about ethics among some participants. I asked about technologies to kind of make sure how open they were to, trying out new tools. And then after that, for the second research question, I decided to test out both the DDSP and the Fourier-based model. So for the DDSP model, I used a neural network building block called Muse, and I heavily commented out the notebook on Google Colab, so it's more explainable in case any one of them is interested to understand what's happening here. But of course, because that's a lot of text and I didn't want it to be overwhelming, I made use of emojis throughout the notebook, so just to have like a sort of visual reference. If there's a star emoji, that just means they have to run the code cell, and if there's a paintbrush emoji, they have to do some like parameter tweaking, as you can see here. And then I also made use of Facebook steam marks for music source separation in case they want to like break apart their audio into drums or bass or whatever. So yeah, prior to this user test as well, like, I asked the participants to get some audio files that they stemmed to. So they had a lot of fun tweaking all of these sound samples. And the second model was the Fourier-based model. It was a very simple sort of project which made use of a simple sort of slider and play button interaction. There were few instructions in the HTML file just to kind of make it more easy, because these tests were very independent. I did not like speak at all during the test. And yeah, all the participants finished both the tests in under 10 minutes, which was great. Here are some of the output examples. So this is traffic signal. And that's how it sounds like after it was run through the model. So that's the trumpet, yeah. Okay, and so that sounded nice, but then there were some examples where the birds one. Because there's so much going on, the flute one. It didn't really sound like the original like birds audio sample, and that's probably because this model only takes up like monophonic audio samples very well, but can't handle a lot of different sort of noises in the same sort of file. Then I also did a user experience evaluation using SUS, made use of Google Forms because of how accessible it is. And this was how it was calculated, which looks very complicated, but it's actually very simple. And these were the SUS scores for both. So anything around like 60 to 70 is good, but of course needs more work. Hence, the Fourier-based model didn't really perform very well. And that's probably because participants mentioned that they were quite stressed looking at the code. And a lot of times, like due to like browser incompatibility, the audio files wouldn't really sound, they couldn't play and stuff. So I guess that maybe reduced the the limitations. Participant pool, they were way too diverse, so I couldn't really do a lot of like statistical tests, and plus most of the participants, they were known like non-verbal orthostatic participants or orthostatic participants with like motor issues, so hence it's not a very representative sample, and there were a lot of confounding variables within both the models as well, but they were both quite different, using different interfaces and different sort of like websites. So I don't think you could compare both those. And interface accessibility as well. Having to look at code and stuff was quite stressful for a lot of participants. But yeah, all participants did mention that this was an interesting tool, and there's potential when it comes to further exploring how it could be used for autistic stimming, because they did enjoy, listening to the same sort of sound sample that stuck in their head and like different sort of variations. But yeah, a lot of work that needs to be done. Thank you.
Our next project is going to be by the student Danush Giridhar, whose work was working towards a body-inclusive AI choreographer.
Hello, my name is Dhanush, and I've recently graduated from my master's in data science and AI in the creative industries at UAL's Creative Computing Institute. My thesis was on working towards a body-inclusive AI choreographer. So, what does AI choreography mean? It is using artificial intelligence-based methods, such as machine learning and deep learning, to generate new forms of choreography. And choreography will be defined as dance movement or rhythmic or artistic expressive motion that is not simply random motion or general human motion, for example, running, standing, or jumping. So, what does body inclusivity mean? It is about recognizing the need of representation for the vast range of body types that exist for human bodies, and human bodies can vary according to various different things such as height, age, and so on. So, choreography. Choreography can be described as a composition of dance movements, and it's generally rhythmic and sequential in nature and for expressive and aesthetic and cultural reasons. And a lot of times the choreographic process is about assembling dancers to produce different dance movements in response to prompts and ideas, and reinterpreting them and trying them out in different ways. And then in the end, the choreographer is the one who composes those movements into a final output. Early representations of the human body were generally through military research that were creating these body models. So, for example, the articulated total body model and the Caesar dataset. And in terms of digital body representation, from techniques were pose-based deformation model, and instead of just using a rigid skeleton, pose space essentially took a space around a skeleton as well in order to understand human movement. And then we had other concepts such as scape and other models that utilize statistical understanding and try to fill in missing information and so on. So, with the history of digital body representation, themes are generally using PCA analysis to group different body shapes together and then develop linear models of body shape from this. And then the Caesar dataset was quite widely used in a lot of this research. And quite a lot of things, such as the understanding of fat and muscle as separate entities and other parts of the bodies, recognizing organs and so on, was not really found in this research. And a lot of times symmetry was also assumed in the bodies as well. So we also have various different models that came out quite later. And for example, the skin multilinear person model is 2015. That's the definitive model now that is widely used. And there are also some other data sets that are used for body movement. So for example, the CME motion capture database and AMAS. So now we've moved from digital body representation to body movement specifically. So motion generation tools, these can include using motion graphs to graph out to possibilities of human movement and then create a motion from that. And there's some other frameworks as well. For example, CNNs, GANs, transformers, various types of machine learning architectures have been used in relation to motion generation. So AI choreography tools, we start off with GrooveNet, and it uses 23 minutes of dance footage and sometimes can be jerky or stuck. But then we move on to another study that uses motion MD RNN, and it's also utilizes an RNN and MDN framework. And then we have AIST, that is one of the definitive choreography models that's there. And then we have Transflower that also aims to unify different data sets to create choreography. The issue is, though, that there's a lack of accessibility in modifying these AI choreography tools and a lack of documentation of how different modifications can be made to the body itself and what motions can be made as well. And so because of this lack of documentation, it can be very difficult for creating better digital body representation, in particular in AI choreography and movement. In particular, choreography and dance is something that can be important for one self-identity and community. And so it is important to look at body representation and ensure that this kind of thinking is embedded when creating these tools. So customizability, body inclusivity, and embedding these ideas. So in particular, the end of my thesis, the real outcome was that creating a body inclusive mindset into developing these AI choreography tools will be crucial in order to ensure that AI choreography can be as inclusive and reach as many sections of society as possible. Thank you so much for your time today, and I hope that you found the presentation enjoyable. If you have any questions, please feel free to email me. After this presentation, there will be a video output that demonstrates a performance output from these learnings. Thank you.
Our next video is by the student T. Lan, whose thesis project was a group recommendation system for music using implicit user feedback.
Hi, I'm T. I'm presenting you my thesis project, a group recommendation system for music using implicit user feedback. So basically, it's a system recommending songs to people at group events like dinner parties, small gatherings. And this contains processing an implicit feedback data set, train a model to learn the group preferences, as well as predict new songs that the group may like through different methods, and then generate explanations for all the predictions. So this will relate to group recommendation system, explicit and the difference between explicit and implicit feedback, and also explainable recommendation system research fields. And the challenges are actually about how to implement implementing implicit user feedback to an algorithm that's designed for explicit user feedback, since we're using an already existing code for a group recommendation system. And then we assess different methods on the group recommendations. And then we try to generate explanations for all the results. So the data set we use is actually trimmed from a large data set presented here, and we have it re-indexed, and we also converted the implicit feedback, which is play count, to ratings by using the algorithm on the up right, if you can see that. And you can see the original data set has a long tail distribution. Well, ideally, we would like much more regulated distribution, like the one in the middle, which is from the Movie Lens 100K dataset, which is widely used in the research and the academy and industry. And the result is pretty good, actually. It's basically the same with the goal we want in the middle. And for the group recommendation part, is there actually can roughly have two methods to recommend. One is view the group of people as just one virtual user and suggesting songs to that virtual user. And the other is like simulate the negotiation process within a group when they're doing the group decision. And in more detail, we actually have three ways to generate group vectors. So it could be utilized in the matrix factorization process and being used as like a user vector. And if you can see the graphic, we have three methods, and the first one is to basically merge all group members' vectors together to have a group vector. And the other two were pretty similar, where they do some computation on the ratings from every group member. And I would say the first two are more like a virtual user approach, and the last would be more like a consensus approach, where they have this weighted process for all the data. So for the matrix factorization, we had some optimizing process to get the best results, where you can see it here. And then for the group recommendation, we generated 10 groups in three sizes, 10 groups for each size, 3 people, 5 people, and 10 people. And then we recommend 25 new songs for them. And we have a parameter called rating threshold, which we'll explain later. So the performance is evaluated with precision and recall value. So the precision is actually the percentage of songs recommended to a group of people that would be liked by everyone. And recall is the ratio of recommended and liked songs to all the songs that could be recommended. And we can see as a result, the first approach is outperforming two others, while it's the same for the recall. But we can see that for the recall, there's a really low value for every recall value, which we will reflect on later. For the explanation part, we actually have two. One is top influences for the playlist, which is presented to tell how every group member is represented in the group by comparing the similarity between user vector and a group vector. And the other is likely enjoyed by. So this is for every recommended music to show how this music would be liked by the group. So overall, we have tried to convert the play count data to rating data, and it works. It worked. And the precision rates using the first method is significantly higher, and it's all based on this data set. And we see that explanation can be generated after the recommendation is performed. And the performance here and the limits here, we can see the significantly low recall value. I would say it's because we only recommend 25 songs to each group, while in the whole data set we have over 4,000 songs. And also there comes the selection bias. Since I trimmed the data set is trimmed from the larger one, it lacks the diversity since all of them are top users and the top songs. Sometimes some songs can be popular enough for every group member to love, while sometimes maybe all the group members have listened to all the songs or most of the songs that we have several left to recommend. So for the conclusion, we had successfully utilized this implicit user feedback, considering there are sometimes limits to obtain explicit user feedback in real-world application. And we see that there's one approach which is called AF is outperforming and works well on this data set. And we had generated an explanation to tell how everyone is represented in the playlist, as well as how every song in the playlist is liked by every group member. So future work may include using a different or larger data set that could have less bias or produce less bias, and also a user test to see how people will react to these explanations and how the explanation would influence their usage of the function. Thank you for your listening. So that's all.
A student from the Master of Research Creative Computing. In this video, I will briefly introduce my research project, a digital collage experience for beginners. Collage is a form of artistic expression that uses different materials to conceive, arrange, and paste in a flat space. It is very free and creative. It connects us to the outside world using elements from already existing external sources, such as newspaper, magazines, fabrics, and so on, to create something personal as an expression of our own thoughts. In this project, in the initial investigation, I invited 6 people who were interested in collage. They participated in my experiment, and I asked them to create some collage in the traditional way. At the end of the experiment, they discussed with me the difficulties they had encountered. So I got some insights here. The first is the time and the space required to collect and store the materials for the collages, and the lack of the creativity for people with no experience in art making. And they were also concerned about the way in which the collages would be preserved. Therefore, I wanted to improve the accessibility for beginners of this art form by digitizing the creation process. Inspired by art journals, I have designed experiments of collage journal software. In this software, users can record their thoughts and ideas and freely express their feeling. This software encourages users to collect material relevant to their own life by taking photographs rather than downloading pictures from the internet. In this software, users can cut the photo manually or use the automatic cutting function. Once the materials have been processed, the user can begin to create the collage. The collages are also divided into a manual way and the automatic way. The automatic collages offers the user more creative options. Once the collage has been created, the user can write comments of the collage to help them preserve the memories of the creation. Each material can only be used in the same piece of artwork. This is to retain the uniqueness of each material, just like the traditional method to create the collage. The connection between the material and the collage allows the user to see which material was used in the creation of the collage, and the text comments help users to record the stories of their creation and make it easy to navigate and display their collages. So then I invited more people to experience this software and got more feedback about it. In this project, I've tried to implement automatic cutting, but I'm still working on the use of machine learning to automatically generate collage. So the half of the project is still like a concept design. So thank you.
I hope you enjoyed watching those videos from our student postgraduate showcase. We look forward to hearing more about you and look forward to seeing applications in the future. Thank you.